I never really know how to start these. Hi, it's me. I'm Derek. I'm the community steward here at ETH Denver, aka SporkDAO. Are you raising your sporks and getting ready for ETH Denver 2023? It's so soon. It's literally in 1 month because this is January 24th and it starts on February 24th. So if you're going, I look forward to seeing you there, and I hope you say hi if you bump into me. In just a moment here, we're going to boot up smart contracts Tuesdays and resume the Solidity tutorials we've been doing for a while now. We do not have a special guest telling us about anything, although last week we did have an amazing interview with Camila Ramos. Cami came and explained what they're doing over at Fuel, and I thought that was pretty sweet, especially because you can write smart contracts in TypeScript and Rust, two super popular, beloved languages, neither of which is Solidity. As for us, though, we're back on the Solidity train. Give me some GMs in the chat. I'm curious who's here. What's up, Beam Me Up Now? It's good to see you. Let's see. Where did we leave off? What's up, Suede? Welcome back. Me Trippy time. Is that who I think it is? I noticed the Trippy. Monday Solidity. Bada boom. Oh, yeah. I got to do the super fancy audio screen sharing thing. Oh, God, life is so hard. Anybody feel that? That life's just super hard? Okay, get our GitHub. Curious, what have y'all been up to this past week? As for me, Camp Biddle planning has been ramping up. For those who don't know, Camp Biddle is a boot camp that we're going to be doing at ETH Denver. It's the first one ever this year, hopefully the first of many. And it's meant to be like a crash course in Web3 fundamentals. So you're going to learn about smart contracts, design, community, marketing, and front ends. Go from like literal, I don't know anything, I just heard about this crypto stuff yesterday, to ready to contribute to a Web3 project, specifically at our Biddle-a-thon over the course of the 10 days. So highly recommend that y'all check that out. ETHDenver.com/Camp Biddle. Tell your friends, especially designers. We need more designers. I can tell you right now that if you apply to the design track and are interested in learning about UI UX, user interviews, Figma, you have an extremely high chance of getting in, because we want to make sure that we make enough space for designers in Web3 to get the skills y'all need to start contributing. So the prerequisites for that program are literally none. And the outcome of that program is experience receiving world-class education from Web3 designers, such as the designer of Uniswap. Why would you not do it? So if you know anyone that's thinking about making a career change, or even just flirting with the idea of trying on a new skill set, I strongly encourage you to tell them about ETHDenver.com/Camp Biddle, powered by Chainlink. Do it. Shia LaBeouf, just do it. We have had 700 people apply to this program that only has room for 250. And like I said, we are still hungry for people to apply to the design, UX, UI, and graphic design track, even if you have no experience as a designer. Specifically, if you have no experience as a designer. This is not for designers. It's for noobs. Okay, I've done my speech. Pay the toll. Damn, if only there was a way to get started in Web3. Welcome back, Andre. Did you reach out to Nather? No, pay the toll. This is not online. This is actually in person. It's going to be very close to where the core event is going to be. It's at something called the National Western. The core event's at the National Western. And this Camp Biddle program is going to be at a brand new building in the CSU Spur complex. That's Colorado State University, excuse me. Called the CSU Hydro Building. They literally did the ribbon cutting ceremony with the governor like a week or two ago. So very nice new building, great amenities. This is why we're not serving bottled water. Y'all can just refill. It's a building called CSU Hydro. You think we're going to have water-based waste? Hell no. They are thirsty. So it's in person. Definitely the biggest obstacle to participating in something like this is that you have to commit to attending the entire thing. Now, it is half days. There's going to be a morning cohort and an afternoon cohort, and those will be separate. Never the twain shall meet. So if you're like in the morning cohort, for example, you show up Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, 6 days, only for like 4 hours at a time. The hard part is having a hotel and being here, which I acknowledge is quite an expense. So if you are considering, let me just say it. This is the kind of thing that would change the course of somebody's career and life if they chose to come to this kind of opportunity and really seized what the potential is here. And we're offering it for free. So the reason I wanted to dwell on this for a moment is I specifically would love, for the help of everyone watching right now, if you shared this opportunity with anyone you know who might be interested in either learning about smart contracts, designing front-end websites, community and marketing, or design. In particular design, I would love to see more applicants there. You have a near 100% chance of getting accepted if you apply to the design track. You have a near 0 chance of getting accepted to the smart contract track because we already have like 300 applicants and we have like room for 80 in that track. Life's hard. Speaking of smart contracts, let's start learning them. When we left off, we were in the middle of Patrick Collins' blockchain Solidity Smart Contracts Beginner to Expert course. And we are, quit with that. We are at storage in Solidity, which is right here. So we are in lesson 7, subsection 16, storage in Solidity. Today we are going to get into the weeds of how memory and storage work on the blockchain and to understand the different places where things can be happening in terms of computation. Like one of my questions as I was learning about smart contracts is like, where does the compute happen? Like we're asking it to do logical operations, right? Like does the whole network run the logic, or like can the person's local machine do some pre-processing in the browser before they send like a more concise request to the network? Like where does the compute happen? I'm not going to pretend I understand the internet very well at all. Some things happen on my computer, sometimes things happen on back-end servers, and it's not obvious to me when it's either. And it seems like modern web development frameworks give you a lot of options and flexibility of whether it's the user's computer or a back-end server or both. So anyway, in the context of the blockchain, we're going to talk about storage, gas optimizations, and then we're going to get into a style guide. I love style guides because it makes it really, it makes you have to do less thinking. If somebody's like, and every new line you indent 4 spaces, great, now I don't have to think about that. And when I pass code back and forth with other team members, all the code looks the same. And even if I completely change it, then when I hit save, if I've set up my IDE properly, it'll automatically change it for me. Beautiful. So we are going to learn a little bit about that and then finish up this section that we've been in the middle of regarding testing. We've been writing tests the past few weeks, except for last week. And we'll see how far we can get here. Let's dig in. Okay, Derek, remember, the version of the repo we're using is from the end of the lesson, and there are consistently errors related to the fact that the variable names are different from where he is here in the middle of the lesson and from where our code is, which is the end of the lesson. For example, on the FundMe Solidity contract, our array of addresses is called S_funders. not funders. And so when we are like, oh, go check out funders, it's like, I don't know what you're talking about. And then we have to say, oh, I meant S_funders. And then it's like, oh, okay, yeah. So I'm telling myself that to save myself 20 minutes. Oh, right. And then the audio thing. Life's hard. Give me 1 second. Okay. Mic check. Great. And mic check. As always, I need your help figuring out whether my microphone and the YouTube video are at about the same volume or not. So let's get started.
Okay, great. We have some basic unit tests here, and we're going to write some staging tests pretty soon. But before we actually do that, let's go ahead and add the gas estimator, and we'll see how much gas these contracts and these functions are taking. It looks like the hardhat gas reporter is already here. So let's scroll down. We'll do gas reporter true. And we won't do coin market cap here, and we'll just look purely at the GUI. So you can just comment it out like that.
Okay. Data boom. Hard hat config. We love hard hat. Makes so many things super easy. All you have to do is learn how to do them. Gas reporter true. Coin market cap commented. Lovely.
Now we'll rerun all of our tests. So we'll say yarn, hardhat test. And in doing so, we're going to get that gas output in that gas report dash text here. So looks like
Where?
that gas output in that gas report
Gas report.txt. Where is that?
dash text here. So looks like all of our tests are passing, which is perfect. Now we can look into our gas report.
Oh, it's in root. Okay. Show me gas report.txt. This is working. This is working. Okay. Let's give ourselves more room to breathe. So this is a gas estimate for how much the different functions, such as the fund function and the withdraw function, would cost in terms of gas as a range, minimum, maximum, and average.
And see what's going on here. All right, well, it looks like the fund me function is taking a decent chunk of gas. The withdraw function taking some gas too. We can see the min, the max, and the average, of course. We can see how much each one of these contracts cost to actually output. We don't really care about the mock aggregator, of course, because we're never actually going to use that. Let's say we look at the average gas for these and we go, this looks like it's actually a lot more than what we originally expected. Is there a way for us to make this a little bit cheaper? We go back to our fund me contract. We look at our withdraw function and we notice something. Oh, there is actually a way to make this a lot cheaper. And it has to do with something called storage variables, or these global variables that we've been working with this whole time. Let me paint you a little picture here. We're going to look at one of the first gas optimization techniques you can take to drop these down. And it has to do, within our FundMe contract, these state variables and how they're actually stored and how this contract actually keeps track of all this stuff. This section is going to be a little bit more advanced. So we'll have a note here saying that this is an advanced section. If you want to skip over it, you can. Because now we're getting into gas optimization.
How we feeling? We want the advanced section or we want to skip over it? Are y'all ready to strap in and learn some pretty advanced stuff? Or are you just here for the easy stuff? Beam? Suede? Pay the toll? Andre? It's about to get a little theoretical, okay? I just want you to prepare yourselves. Juan Geraldo? Oh, sorry, I missed your question, Juan Geraldo. Don't worry about a referral code for applying to be a volunteer. You can apply without. We still need volunteers. Welcome, Asoyaf.web3. Ooh, hot take, Beam. I love it. let's cover those basics. We can always learn gas optimization later. What is after gas optimization? The Solidity Chainlink Style Guide. Section 17 and then 18. Opcodes. Yeah, no, I don't want to learn this right now. Okay, we want 12 hours, 5 minutes, 29 seconds. Oh, and we're there.
We have just learned
Goodbye.
an absolute ton here. Now,
skips 2 sections. We have just learned an absolute ton here.
this next part is going to make some of you mad because we're going to refactor our code one more time. If you don't want to refactor it and you want to leave all your tests as S underscores, you absolutely can. But to other users using our application, dealing with this S underscore is a little bit gross and actually can make our code a little bit more confusing for those who use it. And additionally, right now, all of our state variables are public. And actually internal variables and private variables are also cheaper gas-wise. And we don't need to make every single one of our variables public because anybody can read them off the chain anyways. So one more refactoring that we're going to do is we're actually going to set the visibility of these to private or internal based off of whether or not they need to be private or internal. And then we'll create getters at the bottom of our function here. So minimum USD, we can keep as public because we want other people to know what the minimum USD of our contract is without having to go right through storage. The owner of our contract isn't important for others to know or other contracts to know. So we can go ahead and make this private. And then at the bottom, add a function, get owner. That's a public view that returns owner, returns address. As funders can be private as well. So at the bottom, we're going to say function get funder, and we're going to pass a UN256 index, public view returns address, return as funders of index. The address to amount funded can also be private. So at the bottom, we're going to create function get address to amount funded. And this is going to take an address funder, public view returns UN256. We're going to return amount funded of the funder. We did this one, we did this one, we did this one, and then price feed, function get price feed. This is going to be a public view as well that returns aggregator v3 interface, and that's going to return s underscore price feed. Oh, okay. The reason why we did that is because we want to have this s underscore so that we as developers can know, okay, this is a storage variable. I want to be very careful about how I interact with this. But we don't want people who interact with our code to have to deal with this S stuff. And we want to give them an API that makes sense and that is easy and readable. So we add these getter functions at the bottom to do that. And also changing the visibility can save us some gas in the long run as well, because we're going to be calling from private variables or internal variables, which are cheaper gas-wise. Of course, we do need to upgrade our tests one more time. And like I said, if you want to just leave them with the S underscores, that's absolutely fine. So S underscore price feed is now going to be replaced with get price feed, S underscore amount to funded. It's going to be now replaced with get address to amount funded. We're now going to change S underscore funders to get funder. We're going to change owner. There's nowhere, so never mind. We don't need to change that. And I think that was everything. Let's just look for S underscore. We don't see it. I underscore. We don't see that either. Let's just run our tests one more time to make sure we refactored it correctly. And it looks like we did. Awesome. Okay. We have just learned a ton. We've refactored our code a ton, and everything is starting to look really, really good here. One more gas optimization we could make, and an optimization for our errors as well, is we could update all of our requires to instead be reverts. Because with our requires, we're actually storing this massive string, this massive array of text on chain. These error codes are much cheaper, but that's optional if you want to do that. The whole reason we were doing this is we were going through the style guide and updating things here. So we have public, internal, private, and the bottom is going to be our view/peer functions, which they are. They're just all these getters that we just added. So now our style in here looks good. We've learned a lot about gas. We've learned a lot about storage. This is fantastic. Let's do a quick refresher on everything we just learned because we went through a lot right there. And like I said, this is one of the harder parts of this course. Any variable that is changeable that we want to persist across contract executions and transactions, we save to a giant array called storage. This array is sequentially indexed starting at 0. So the first variable, the first value that we have in our contract gets stored to the 0th index. The next one gets stored to 1, and so on and so forth. Dynamic arrays and mappings and other dynamically sized objects use a specific hashing function that you can find in the documentation to determine where the elements of those dynamic data structures go. Memory variables, constant variables, and immutable variables don't go in storage. And one of the main reasons talking about storage is so important is because the opcodes for loading from storage and for reading from storage and writing to storage are incredibly gas expensive. So in everywhere we can, we want to reduce the amount that we read and load from storage. And it's one of the easiest ways to save gas and try to optimize our code to be gas efficient. Like I said, some of this gas stuff can be a little tricky and a little bit confusing. So if you don't get this right away, it's okay. It is totally fine. If you're a little bit confused and you're like, what is he talking about? Like I said, this is some of the more advanced stuff. It'll come the more you work with Solidity and the more you work with everything here. So don't let it stress you out. Don't let it stop you from continuing. You're doing fantastic being here so far.
Oh, thank you, Patrick.
We've written some really good unit tests. Let's now write some staging tests. And these are the tests that we can use on an actual test net. This is a test that we're basically going to run after we've deployed some code just to see if everything is working approximately the way we want it to. So let's go ahead. We'll create a new file here. We'll call it fundme.staging.test.js. And it's going to look really similar to what we were just doing with our unit tests. And we're going to assume this is on a test net. So these are tests that we're going to run right before we deploy this to a mainnet. This is the...
Having it here written already feels a bit like students that are starting to use ChatGPT to write their essays. Like, oh, I don't even have to do the assignment. I could just watch him do it. Let's try that for the sake of time. Let's just let what we have be what it is and watch him do it in full screen. We could talk about it along the way.
Last step in your development journey. We want to just make sure that everything is working approximately correctly on an actual test net. So what we're going to do is we're going to do the same thing. Describe fundme. And I'm going to go a little quick through these tests here because we've basically written this type of test before. So we're going to say before each, it's going to be an async function. And we're going to do the same thing as our unit tests. So we're going to have a fundme variable. We're going to have our let deployer. We're going to have our const send value equals ethers.utils.parseEther of 1. And in here, we're going to do const get named accounts equals require hard hat. We're going to say deployer equals await get named accounts. We're going to wrap this up. Do dot deployer. We're going to say fundme equals await ethers.getContract. Fundme, comma, we're going to connect it to our deployer. We're not going to deploy this. We're not going to do any fixtures like we did in our unit tests because in our staging tests, we're assuming that it's already deployed here. And we also don't need a mock because on a staging, we're assuming that we're on a test net. Now we can actually wrap this whole thing to make sure that we're on a test net by using our helper config and looking for our development chains. We can say we only want to run our describe bit if we're on a development chain. So first we'll say const development chains equals require. We'll pull that helper config in and we'll say development chains dot includes network dot name. And we'll basically say, we'll say if developer chains dot includes network dot name, we're going to skip. And we can actually skip using this. We're going to use something called a ternary operator. It's basically like a one-liner if statement. And you can think of this as a special type of if. I've got a link to this in the GitHub repo associated with this course. And here's some JavaScript documentation showing it in action. We say, okay, return is member. And if it's true, have it be $2. Otherwise, have it be $10. And that's pretty much it. So another way of thinking about it is like, you could say let variable equals true. And then we could say let sum var equals variable question yes or no. Sum var will end up being yes because variable is true. If variable was false, then sum var would be no. So it's literally saying if variable, then sum var equals yes, else sum var equals no. These lines are literally the exact same thing. This one is just a little bit more succinct. That's really it. So that's what this operator does. We're going to say development chains.includes network.name. So if our network is a development chain, which we're going to import network as well from Hardhat and Ethers as well, then we're going to do describe.skip. And this tells our test to just skip this whole describe. And then we're going to put this little colon here thing and save, and boom. So now we're only going to run this if we're not on a development chain. And we want to take this exact same syntax. We'll go to our unit testing here, and we'll do the exact same thing. We'll paste it. We'll have this be the opposite by putting a little not here, sticking that colon in. So now,
Very concise. Do we have something like that? No, we do not. Let's do it.
now our unit tests only run on development chains, and our staging tests only run on test nets.
Okay, we need to get was it require? Require. And network from Hardhat. Okay.
Perfect. That's what we want. Allows people to fund and own and withdraw. And this will be an async function, of course. And we probably could make this pretty robust, but we'll just say await fund me.fund. Value is going to be the send value. And then we'll say await fund me.withdraw. Assert equals require try. And then we'll do kind of a lame final one. We'll say const ending balance equals await fund me.provider.get balance fund me.address. And then we'll say assert dot equals ending balance dot toString, comma, 0 as a string. We're only going to run this on a testnet. I'm just going to give you this one more run to show you it in action. Feel free to skip this part again because we are going to be working with a testnet. I'm going to run yarn hardhat deploy -- network rinkeby. And it's going to run through our deploy. And after it's all deployed, we're going to run our staging tests to make sure that everything works even with a price feed on a real testnet. And I need to do const development chains equals require .. help our hardhat config. So now if I run yarn hardhat test, we'll see just our unit test get run. But if I run yarn hardhat test -- network rinkeby, we're not going to run 9 tests. We're only going to run our singular staging test. And of course, this is going to be a lot slower because we're on a testnet. Now that we've written all these tests, we can write a couple of scripts, and then we're going to finish this out by pushing this up to GitHub, making this our first smart contract GitHub repository. When it comes to the blockchain, when it comes to smart contracts, interacting with the community, interacting with open source, being a part of GitHub or GitLabs or whatever Git hosting service you're using is essential to being successful here. So let's write our scripts, and then we'll upload this to GitHub to start building our portfolio. So first,
question from O2 Glass. What kind of contract are they writing? This is an example contract for the sake of our learning. It's not super complicated. It's not super useful, but I mean, you could say it's pretty useful. It's called Fund Me, and the idea of the contract is that people can donate or fund this contract by declaring the fund function and sending some ether to it. And then the owner of the contract can at some point withdraw all of the ETH that has been funded and sent to that smart contract. So 2 basic functions, fund and withdraw, including a couple other things such as keeping track of who has funded. Thanks for asking.
First, we're going to create a script to interact with our code called fund.js. And this is going to be really similar to our tests. And this way, in the future, if we want to just fund one of our contracts very quickly, we can just run this and we can do it. We're going to do the same thing that we've been doing. We're going to do an async function main. And down below, I'm just going to copy paste this because we're going to be copy pasting it a lot. We're going to paste this little syntax here. So let's write a script that allows us to fund our contracts. So first, we're going to need const get named accounts, just like in our tests, equals require hard hat. And we're going to say const deployer equals await get named accounts, just like that. And then we're going to say const fund me equals await ethers.get contract from fund me, comma deployer. Literally almost exactly the same as our tests. Then we'll do a little console.log funding contract ... and we'll do const transaction response equals await fundme.fund. And for the value, we'll do something like ethers.utils.parse ether of 0.1 or something, whatever you want to do here. We, of course, need to import ethers, which it looks like we already have. We'll do await transaction response.wait for one transaction. And then we'll do console.log funded. We can run this little script by running yarn hardhat node. We'll run a local node with all of our contracts deployed. We'll see if our script looks okay by running yarn hardhat run scripts fund.js -- network localhost.
Okay, I'm super curious. Let's see. First, how do I clear console? Goodbye. There we go. Is this big enough? Good enough? Text size? Hardhat node. Lovely. We get another terminal going. Go hardhat. What are we calling it? Test. Hardhat. Run script / fund.js network localhost. I think I messed that up slightly. Scripts / fund.js. Scripts / Wow. That feels nice. Okay.
And it looks like it's funding great. Let's now write a withdraw script, withdraw.js. And we can even leave our localhost node running because we're going to withdraw the funds that we just funded it with. So we're going to do the exact same setup here. We can even copy this main bit to our withdraw. Go to the top. We'll do async function main. We'll say const deployer equals await get named accounts, which, wow, I hit enter and my VS Code auto imported it. That's pretty nice. Maybe yours will too. Maybe it won't. If it won't, you just got to write it out or copy paste from the other one. And then we'll do const fund me equals await ethers.get contract fund me course. And this is going to be the exact same. Now we're going to do console.log funding We'll say const transaction response equals await fund me withdraw await transaction response wait one, then console.log got it back. And we can test this out by running yarn hardhat run scripts withdraw -- network localhost. We'll see if this works. And cool, and our script is working. Fantastic.
Let's see. Can we withdraw? Because we already have withdraw.js from when we forked the repo. Lovely. Lovely.
They crushed out 2 scripts incredibly quickly, and now we have a way to easily interact with our code, with our contracts, if we want to, via a script.
I hope you can appreciate the power of these scripts. They're pretty ugly in terms of syntax, especially compared to what they're replacing, which is if you were working in Remix, for example, and you deploy, and then you're just clicking around, like clicking the setter functions, like typing in the boxes, like deposit or fund 0.1 ETH, and then withdraw 0.1 ETH. But every time you make a small change to your contract, you have to redeploy and then manually click all those things to set things up. And the tests and scripts that we're writing here in Hardhat save you so much time, especially when you're past like your first baby steps of writing your contract and you're like iterating on certain functionality and refactoring things. You want to be able to test all of these different pieces of functionality to make sure that nothing broke. I pity the person that uses Remix only and is clicking on things exclusively as their method for checking whether things work the way they expect. That being said, in the context of a hackathon or a bidathon like ETH Denver, yeah, it's totally fine to just deploy it on Remix and then click your buttons real quick.
There's actually one more thing I want to show you before we actually work and we push all this wonderful code up to GitHub. In our package.json, I've shown you a little bit of this before, but we can add this scripts section to make our lives a lot easier and condense all these long tests into a yarn script for us. So usually what you'll see in common package.jsons is you'll see a list of these in here for people to look and just automatically run. One of the most common ones is going to be test. And to run test, we're going to do yarn hardhat test. So now, instead of running yarn hardhat test, someone can just come to your package once this is saved and just run yarn test. And this will grab this test from your script section and it'll run yarn hardhat test and bada bing, bada boom. Okay, cool. What else do we probably want to do in here? Well, we probably want to have a test staging section that'll run yarn hardhat test -- network Rinkeby. I'm not going to run that, but that's probably something we want to have in here. We're probably going to want some linting. So we showed you briefly that linting thing. So we'll have a yarn lint, which will just run yarn sol hint, and then we'll just have it sol hint the contracts folder and anything that's star.sol. So now if I run yarn lint, it'll run sol hint and all of our code here, and it'll give us some warnings here, which we can pretty much all ignore. And sol hint actually has an auto fix that we can add by doing yarn lint fix. We'll say yarn sol hint contracts / star.sol. We'll do -- fix. So now if we run yarn lint fix, it'll auto fix, which there's nothing to auto fix, so nothing happens, but it's good to have anyways. And then we can do our formatter, which is going to format our code, format, which will do yarn prettier dash dash write, and we'll just do a period to do everything. And then we can just use yarn format. And it's going to fix it's going to fix everything for us, which is great. And then we finally can have coverage by running yarn hard hat coverage. Now we can just run yarn coverage. It'll give us this wonderful little coverage report. Awesome. So our package is looking fantastic.
Hey everyone, your package is looking fantastic. Question from Joaquin. What do you think about Foundry? I appreciate the question. I'm not going to pretend I'm an expert, but what I do know about Foundry is that behind the scenes, it's comparable to Hard Hat for the purposes of what we're learning here and comparing them. If you don't know about Foundry, it was released recently and is written in Rust, which means it's really, really good and secure and fast at doing things like compiling and running all your tests. But more importantly, in terms of the developer experience, here we can see as we go through this course that we need to know two languages, basically. We need to know Solidity so that we can write our smart contracts. And we need to know JavaScript or TypeScript so that we can interact with a lot of the hard hat stuff, such as the script.js we just wrote. So Foundry is that you can write your tests also in Solidity. So if you only wanted to be working in one language as you go through your smart contract development process, everything from the contracts to testing and staging and deploying, you can write it all in Solidity, which is a nice DevX, I suppose. So there are definitely reasons to try it out. I tend to be of the school of thought, like if I'm going to learn something, I want to learn the thing that has more of a community and more resources around it, even if it's not optimized for some other things. So for example, even though I'm a solo dev, or like, one of several on a small team, I think it makes sense to know React. Some other people might say, no, just go learn like Vue or Svelte. This is the exact situation where if you're the only person on a team that's not opinionated on their stack yet, that you do get to use other frameworks that have like a better developer experience or better syntax or whatever you want to call it. And I'm like, yeah, but I'm a noob and I'm Googling stuff constantly, and I'd rather use the Stack Overflow that has like 100,000 answers compared to the one that has like 2,000 answers. So I'm just going to go where the people are. Those are my thoughts.
Maybe we'll even come into package.json. We'll give this a name. We'll call this hard hat fund me. Give it an author, which is going to be your name. So I'm just going to say Patrick Collins, and we'll give it a version in here of 1.0.0. Oops, and let's do hyphens instead of spaces. Oh, and one more thing. We're not using ESLint, so all this ESLint stuff we could dump. And we could delete the yarn.lock and reinstall, but whatever. We don't have a README, but that's okay. If you want to go back, like I said, go check out that best README template and go update your READMEs to make them look as awesome as this. You could do that as well. But other than that, we've got an awesome code repo here.
Let's push.
What do we want to do with it? Well, we've been playing around with GitHub so much. We've been looking at all these GitHubs. It's time for us to join GitHub with our first repository. Let's go ahead and let's make this happen. In the Lesson 7 Full Blockchain Solidity course, there is a link to this GitHub quick start that we're going to follow to set up our first repository. This is going to be the moment where you are starting to build your portfolio. Building a GitHub is borderline crucial for your development journey. It's going to be your portfolio. It's going to be where you say, hey, look at all the cool projects that I'm engaging with, that I'm working with, that I'm participating in. If you've already made GitHubs before, I highly recommend you still push this up to GitHub as proof that you've done it. And then you can...
Of course. Yeah, careful of shiny object syndrome, Joaquin. There will always be a new cool thing. And as a beginner, I would recommend, this is just personal opinion, dialing in like what foundational fundamental skills you want to have, such as TypeScript or Solidity. And then from there, you can play with whatever you want. But it's really crucial at this beginner stage, especially to take your precious time and energy and motivation and funnel it into some quick wins. You can start to build momentum And that's why, like, for example, I think Rust seems super cool. I wish I knew Rust. And I'm not going to bother learning it because it'd be way more useful to me to know TypeScript. And that's within reach of me as someone who knows basic JavaScript. Whereas I would need to know so much more computer science and a whole new syntax to be able to write in Rust. Just so what? I can like make a CLI tool. Yeah, like Rust is great and it's like top of the charts every year for developer experience, but like it's really hard to learn and I don't know, it doesn't seem worth it. So in other words, having your own set of priorities and sticking to them is crucial.
And also tweeted at me saying, hey, look how far I've gone. Look where I've done. Look at how fantastic I'm learning smart contracts and being incredibly excited about it. Now, this quick start will walk you through creating a repository, creating a branch, and teaching you all this stuff. We're going to follow the instructions from the GitHub documentation about adding locally hosted code to GitHub. So we already have a project and we're just pushing it up. Since the Windows users are using WSL, you can just follow the Mac or Linux instructions here.
All right, let's make a bunch of changes and push to GitHub. Stage everything. Look at me using the GUI. Who needs a command line? It's good enough. What do we do? Watch. No, I always find this part the hardest. What is the message? Beam, what are we doing here? Message. And are we going to commit to main branch? I wonder. Probably. Finished tests and scripts. Tidied up. Root of repo. Tidied up package. .json. Yeah. Smash. Oh, I'm committing to main on his? Yeah, no. We don't want to do that.
First thing that we're going to do is in your GitHub profile or your GitHub login, you're going to hit this little plus thing and hit new repository. You can call this whatever you want. Let's call it hard hat fund me free code camp. You can put a description if you want. Learning from free code camp and Patrick about smart contracts. We'll make it public because we want other people to see you being fantastic and learning smart contracts. We'll leave this blank and we'll hit create repository. Now, this is our public code repository. This is our first one. If you've done these already, this will be your first smart contract one. It even has some instructions in here that teaches us how to create a new repository from the command line. You can follow this if you want, or you can follow like so. The first thing we're going to do is we're going to initialize a Git branch. And from way back when, you should already have Git installed. Remember, you can check by running git -- version like this. Git is a little different from GitHub. Git is known as version control, and it allows us to make changes to our code, but keep a history of all the code changes that we've made. GitHub is a place where we can push all of these changes and keep track of all of our code. So the first thing that we're going to do is we're going to create a new branch, and I'm not going to explain Git and working with Git too deeply, but if you want to learn about Git, Free Code Camp, of course, has a video on Git and GitHub for beginners. So we're going to create this new branch with git init-b main. Now your Visual Studio Code might automatically start formatting some stuff. And if it does, that's great. And if it doesn't, don't worry about it. But what you'll see here on the left is you'll see some stuff is green and some stuff is gray. Open back up that .gitignore. You'll see that all the gray stuff is the stuff that we have in this .gitignore. This is intentional. This is what we want. This is just some highlighting saying, hey, this green stuff is what you're working with on GitHub, and this gray stuff is what you're not working with in GitHub. And that's what we want. You don't need to push artifacts or cache or coverage or node modules. People can install and compile on their own machines. We definitely don't want to push up our .env if we're using a .env, and we don't really need to push up coverage.json either. The rest of this, we do. So So now what's next after we initialize our main branch? You now should be able to run git status in your terminal and see this huge red output of all these things that are untracked and we don't have any commits for. What we can do now is we can stage all of our code with git add period and then commit it with git commit. We're going to run these one at a time instead of together.
Dang it, I have divergent branches. My branches diverged. Okay. What is rebasing? I do want to rebase. Lovely. I thought. Lovely. All right. We rebased. Hell yeah.
Before I run git add, I'm going to add deployments to this list too, because GitHub doesn't really need to know about all the different deployments I make, especially when I make a ton of deployments to my local host. They don't need to know. So we're going to add that too. Then we're going to run git add dot. And if we do a git status now, we can see all of our code has been staged for being committed, for being a part of this history of our code. And then take a quick look at all these files and make sure your .env file is not and never in here. So now I'm going to run git commit -m and then this message for our commit. Okay. So we'll run git commit -m. We can say initial commit or whatever you want in this message here. First commit, initial commit, who cares? And it's going to say create mode, blah, blah, blah for all of these files. And if we do git status now, it's blank. On branch main, nothing to commit. And then you might get something like this. If you've never worked with Git before, your name and email were added automatically. We're a little bit confused here. We'll talk about this in just a second. So next, what we can do is we're actually going to copy the URL of our GitHub repo. So you can grab that just by copying.
Darn it, I was still pushing to his. How do I tell this that I want to be on a completely different repo? How do I sign into GitHub? Okay. And so here's the problem, folks, and I genuinely need help. I'm trying to push my code. Beam's already on it, you little hero. Set your remote to your repo. Okay, how do I do that? How do I set my remote to, where did it go? This one. This blank boy. So what I want to do is push it here. Okay, yes. See, sure enough. Copy the clone link. Would that be up? Where would the clone link be? Oh, over on his? I'm curious to try this one. Excuse me. Woo. All right. Nope. Nope. Give me the whole thing. There we go. Get remote add origin. The URL. Remote origin already exists. Bizarre. Get branch capital M main. Get push origin main. Uh-huh. Okay, I typed in a password. And it's still trying to access his. Try get remote -v. We're still on his. How? I'm confused why this didn't do what I thought it would. Yeah, I guess I don't know what these words mean. What is a remote and what is an origin? Remote is a server or place where the repo is hosted, and origin is the default when you first clone. Okay. So what is recommended? Do I need to do some kind of cloning? Get remote remove origin. Okay. Just so you know, over on Twitch, I've got Beam telling me to do remove the origin and then do the add. And then over on YouTube, I've got Rami Majub telling me to do remove origin and then do the get add. In other words, this is a beautiful community, and I love you both for coming up with the same answer at the same time to help me out. This is why we go far together. And then we do get add. Right? Excuse me. Thank you. Okay. Curious. The remote add. Oh, the one from the. Yep. No error. No error. Copy paste developer. Copy paste developer. Hey, it's working. How many times am I going to have to do this? This is super annoying. Yay, things happened. Ta-da! And you know what that means? Your boy's profile has a green square on January 24th. Let's give it up. He pushed to GitHub today. Wow. really showing up, really doing a lot of hard work on Wednesdays. Speaking of which, tomorrow, as we wrap this up, is Front End Wednesdays. Let me see if we have a special guest for tomorrow. Indeed, we do. Vito Rivabella from Alchemy. Yeah, Alchemy is pretty important. Alchemy actually is one of the sponsors not only of ETH Denver, but of this bootcamp, if I'm not mistaken. So I look forward to speaking with Rito on this same location, whether you're watching on Twitch or YouTube or Twitter, 3 to 4 p.m. Mountain Time tomorrow. We'll learn a little bit about what Alchemy does, what it offers folks who are building decentralized apps or dApps, and what options you have for using Alchemy to make your development experience much smoother and better when you want your front end to be able to read and write to the blockchain. So join us tomorrow, same time, same place, to speak with Rito. Vito Rivabella? I misspoke. Vito Rivabella. Excuse me. Okay. Thank you for your help. This was a huge push. And then let's see where this transitions.
Here, or right at the top, that URL right there. And what we're going to do is we're going to add this as a remote repo. To do that, we'll do git remote add, and we'll give this remote repo a name. For us, we'll say origin, and then we'll paste that URL there. We're now saying the origin remote repo is going to be at this URL. If we run git remote -v, we can see that the origin repo for fetching is at this branch, and the origin repo for pushing is also at this branch. So when we want to get new code, aka fetch code, we'll fetch it from here. And if we want to push code up, we want to give code to the GitHub, we'll also get it from here. So now we've set the new remote with that remote URL. Now we're going to actually push the changes to github.com. The way we do that is with git push, and we pick which remote we want to push to, and we're going to push to origin, and then which branch we want to push to, which we're going to push to main. It'll probably prompt you for your username and your password and maybe your email and everything. Now, if authentication doesn't work for you for some reason, you can come over to settings, or if you scroll down to developer set,
skip,
and the GitHub discussion associated with this. Once you add a repo with all the code, you should absolutely celebrate. If you like, you can shoot a tweet. The Web3 community and the blockchain community is absolutely this collaborative space. So Twitter Crypto is where a lot of these people congregate to share ideas. So definitely be sure to celebrate and share this and be really, really excited. And shoot a tweet out like this. Give your friends a high five, share it on Twitter, share it on Discord, share it on Reddit. Be excited for how far you've gotten. We've got a lot more to go, but by completing this part, you have done fantastically. And I am so excited for you to start the next section. Now, we're not going to go over the TypeScript edition of this because there's nothing really new here. However, again, if you want to see TypeScript, feel free to jump into the GitHub repository associated with this course.
Lesson 8.
Right.
Dang it. He moves so fast.
Repository associated with this course.
Lesson 8. HTML and JavaScript fund me, where we finally go front end. Give me that timestamp. Bada boom. That's going in the Discord, baby. Thank you so much for your help. B Shamba. Beam me up now. Rami Majub. We're going to pick it up at lesson 8 next time. Lesson 8 is going to be about full stack, aka front end. But we're not going to do that 1 week from now because we have a special guest. You're going to have to stay tuned to see who it is. But for now, thank you for joining. Wait, let me get a cute background. There we go. Thank you for joining Smart Contract Tuesdays. Tomorrow, as I said, is Front-End Wednesdays and then Theory Thursdays. And then on Friday, we wrap it up with Raise Your Sporks, the road to ETH Denver, preparing to biddle at ETH Denver 2023. In other words, we got stuff going on all week. If you want to know what's coming up next, you could check out the community calendar, check out our Discord, and check out our Twitter. They may not all be up to date. It requires a lot of manual work. I apologize for that, but we try. In the meantime, I appreciate you all. And if you need anything, just ping me. I'll probably be super slow to respond, honestly. But you can still try. Okay. Have a great rest of your day, everyone. Bye. Bye, Bishamba. Bye, Beam Me Up Now. Bye, Suede. Bye, Rami. Bye, O2 Glass. Bye, Crypto Artsy. Bye, Joaquin Moreno Atunya. Bye, Asoyaf.web3. Bye, Andre. Bye, Pay the Toll.